Okay, hi. So today we are going to be working with rational expressions or rational function, right? A rational function is a fraction involving two uh, algebraic expression, right? So as you can see, x minus 3 divided by x plus 1, x plus 3, right? So when I'm working with a rational expression as or a rational function as any function, you have a domain. And as a review, domain is the values that you can substitute for x, making the function defined or real, right? So in this case, it's telling find the domain of each function and find any point of discontinuity. What is the point of discontinuity? It's those points that, as the word says, are not does not make that graph of that function continuously, right? And I want to determine if those discontinuities are removable, so they are wholes, or non-removable, so they are asymptote. So let's see what we can do. Okay? So a fraction, you know that my denominator cannot equal to 0. So I'm just going to equal to 0 my denominator, right? And solve that equation. X plus 1 equals 0, x plus 3 equals 0. So x equals negative 1, x equals negative 3, right? As you can see, I cannot simplify any of those expressions. So that means that those two expressions, those two, are non-removable or they are asymptotes. Asymptotes. In another video, we're going to watch how we graph and the meaning of that asymptote, right? So in this case, x equals negative 1 or x equals negative 3. So my domain is all real numbers except negative 3 and negative 1. See? Okay. So my next equation, my first step, I'm going to check if I can simplify anything. As you can see, I cannot simplify anything because none of my expressions are the same. So I'm going to equal to 0 my denominator, as you can see, and you know that the only way that this expression is square equals 0 is where x plus 1 equals 0, so x equals negative 1. So this is a non-removable 0 or an asymptote. So my domain is all real numbers except negative 1. Next one. So I'm going to start by factoring anything that I can factor. So x plus 2, right? Because I have a common factor right there of x. And my denominator, two numbers that you multiply and give you 18. You subtract and give you 7 are 9 and 2. This is going to be negative and positive. As you can see now, when I simplify this expression, I can cancel out the x plus 2. But I'm going to keep that discontinuity. So x minus 9 equals 0, x equals 9 is a non-removable asymptote, right? And x plus 2 equals 0 because I can cancel those out when I simplify this expression. I can simplify that one with that one right there. That means that negative 2 is a removable 0. That means that is a hole on the graph. Okay. So my domain is all real numbers except, even though I can cancel it out, I have to keep as a restriction. Okay. For the horizontal asymptotes, it's a little bit easier because we are just looking at the degree of the polynomial. And to review, the degree is just the highest exponent of the variable, just one variable, right? So in this case, my degree of my numerator is 1. The degree of the denominator is 1. So we're going to look at that information right there. Right? So when the domains, the degrees are the same, it's telling you that the asymptote is the division of the leading coefficient. So in this case, my horizontal asymptote is y equals the division of negative 2 over 1. That is negative 2. Why? Because the leading coefficient on the numerator is negative 2 and the denominator is 1. Right? Now, my second exercise, I'm going to check the same. So the degree is 1 on the numerator, the degree of the denominator is 2. So that means that the degree of the denominator is less than. So I'm looking at this graph right here, where the denominator, the degree of the denominator is greater, is less. The degree of the denominator, is greater than the degree of the denominator. It's less than the degree of the denominator. So that means that my horizontal asymptote here is just j or y, equals 0. Again, if the degree of the denominator are the same, then it's the division of the leading coefficients. If the degree of the numerator is less than, it's y equals 0. And if the degree of the numerator is greater than the degree of the denominator, there's no horizontal asymptote. That's it. Okay. So for this part, I want to simplify each rational expression, right? So, and I want to state the restrictions of the variable. So in this case, I'm going to go and I'm going to start by factoring out. I'm going to check if I have a common factor right there. So this is the same as you can see, between 4 and 12, it's 4. So it's z minus 3 divided by the common denominator, or common factor on the denominator is 8. So I have z plus 3, right? So I can simplify the 4 and the 8. So this is the same as c minus 3 divided by 2 times c plus 3. My restriction is what makes the denominator equal to 0. So c plus 3 equals 0. So c, where c doesn't equal negative 3. On my last step here, I'm just going to distribute that 3. That's it. Let's see the next one. Again, I'm going to start by factoring out. So 3 times x minus 1 divided by x times x minus 1. My restriction, before I simplify, I want to state those restrictions is where x minus 1 times x equals 0. So as you can see, I have two factors with variables different on the previous exercise where that common factor down here was a number. So this now I gotta keep it. So x equals 0, x minus 1 equals 0, so x equals 1. Those are my two restrictions, right? Because I'm not asking you to write the domain. We can just keep it like that, right? So in this case, I can simplify or cancel out the x minus 1 with the x minus 1. And I just have equals to 3 over x. That's it. The next one, again, I'm starting by simplifying by finding a common factor. My common factor here is 3x. So I have 3x plus 2. My common factor on the denominator is 12. So I have 3x plus 2. Again, before I simplify, I'm going to equal to 0 my denominator, because this is 12. That's not going to change that as a constant, so I can just act equal to 0, 3x plus 2. 3x equals negative 2. 3, so x equals negative 2 thirds. So x cannot equal x. Right? So now I'm going to simplify whatever I have in common. So I can cancel out the 3x plus 2. I can simplify that 3 with that 12, and that becomes a 4. So the simplification of this is 3 is x over 4. And the last one. It's a little bit different because we have trinomials. So I'm going to start by factoring out that negative, because when you have a trinomial, it's easier to factor when the x squared is negative, is positive, right? So I'm going to factor out that negative. When I factor that negative, everything changes to its opposite, divided by x squared minus 8x plus 15, right? So now we can factor two numbers that you multiply and give you 12, and you subtract and give you 1. So I have x plus 4, x minus 3. On the denominator, two numbers that you multiply and give you 15, and you subtract and give you negative 8. So in this case, it's x minus 5, x minus 3. Okay. Before simplifying, I'm equaling to 0 my denominator. X minus 5 equals 0, x minus 3 equals 0. So x equals 5, x equals 3, so x cannot equal any of those two numbers. And now I'm just simplifying x minus 3 with x minus 3. So I have negative x plus 4 divided by x minus 5, and I'm going to distribute that negative. So negative x minus 4 divided by x minus 5. And that's it.